All right, let me minimize this so I can actually see it. Okay, this is yeah, very brief. I'm going to try to go through it pretty quickly because it's got 16 slides. But grounding and fusing is kind of an important thing, especially when you're working on the old AA5 radios with the hot chassis. Um, in general, why is anything grounded? Well, the power companies ground one of the lines coming out of their uh, generators, and they do that to keep the atmospheric, mostly to keep the atmospheric from building up a static charge on their lines. Kind of ties everything down so that the hot lines are only, whatever X amount of voltage to ground. Um, and of course, if there are lightning strikes and things like that, that's going to affect it. But they do tie down one of the lines all the way basically to your house. When the power transformer coming into your house, they have center tap typically grounded on the supply side, and when it comes out to your house, they have it grounded at the pole so that it's not floating. And it also, again, makes sure that no grounded metal enclosure can be at a voltage higher than the earth at which you stand. So if you have a metal box, for example, and a hot wire short circuits to it, it will pull it down toward ground and hopefully trip a circuit breaker so that you don't have a refrigerator or whatever that's 120 volts above the ground where you're standing. So if you touch it and you're standing on ground or touching something like a water faucet, the current could go through you, if that makes sense. In your house, in the main panel, you've got, I don't know if you can see my cursor or not here. You have your mains coming in, your two hot wires that feed a pair of bus bars where the circuit breakers clip onto. And each one of these hot wires would be 240 volts between them, but 120 volts between each one of these and the neutral, which is also grounded. I don't know if you all can see my cursor or not. I'm trying to point out these things. The reason is because the phases of these are opposite, and this goes to the center tap of the transformer, if that makes sense. They also, at the main panel coming in of a building, they tie this to ground through a series of ground rods. And this is the only place where the neutral bus can be connected to the grounding point, is in the original panel coming in. And the reason they do that is if there's an open circuit somewhere, either accidentally or because somebody's working on it, you could back feed 120 volts to a neutral that's broken, and then you grab hold of the white wire and get a shock. If there's a short circuit, again, to your refrigerator, radio, or whatever, it actually goes to the ground wire, which goes back to the neutral, which causes there to be a short circuit seen between any of these, either of these hot wires and neutral. And hopefully that's going to, it's supposed to trip the circuit breaker, basically. You cannot just connect your radio to earth. Some people do this with antennas, but that's different. There is not enough current, is not enough current's going to flow through the earth to substitute for that ground wire going all the way back to the panel and connecting to this neutral bus. You know, there might be 1,000 ohms or 10,000 ohms, depending on the earth, how wet it is, etc. Between that neutral bus, again, we're trying to throw the ground and say that, oh, my radio is grounded when you've got, you know, a 2-wire cord. Does that make sense, everyone? I hope.
Yes.
Okay. Again, the main purpose of the ground connection is, got an internet connection unstable. Hopefully I'm still on. The main purpose of the ground connection, again, is to provide a very low resistance back to that mains neutral bus on a dedicated wire to open any circuit protection immediately upon a short to the chassis. By being the neutral bus also being tied to the earth ground current, leakage to that chassis that is insufficient to throw a circuit breaker or blow a fuse, the earth grounding of the bus will limit how much voltage can build up on the chassis above the earth on which you stand, or grounded objects may touch, water faucets, etc. Say there's just, you know, 100 milliamps. We'll just say that because that's the standard at which that's fatal. 100 milliamps leaking, it's not going to trip that circuit breaker unless there's a dead short. But it would still, if the radio chassis is grounded, it would help pull that down so that the current would flow to ground instead of, even though there's some resistance there, because maybe it's just a transformer leaking to its cabinet and then back to the chassis. Okay, so that's another good reason to ground that radio to the green wire that goes to the pin that goes into your socket, back all the way back to the neutral bus and is tied to ground. A typical is unmodified here. The better ones in the later days, called UL rated radios, had the common negative to the B minus, basically. This symbol here is actually separate from the metal chassis. So because these plugs were unpolarized, you could plug them in either way, and this side might be hot or this side might be hot. And electrically, it doesn't matter. The radio is just going to see that. Go ahead and generate from the chassis. Okay. And it is connected typically by a small capacitor.
Your audio is dropping out a lot.
Yeah, we're missing your audio.
I'm sorry.
To some degree, but
okay,
we can hear you now.
Okay. Can you hear me now?
Yes. Go ahead.
Okay, I don't know what happened there. I don't know what happened there. I don't know where I cut out. But you will see on a UL rated radio, and this is 1950 standard radio. 1950 standard is not necessarily the current standard for safety, but there will be a capacitor, oftentimes shunted by a 330,000 ohm resistor or something like that. And this will take any radio frequency between the chassis and the ground and make them electrically the same, so that your IF cans and shielding and things like that will be grounded through this. But if there is a short circuit between the B minus, which might be hot, you got a 50-50 chance. This will only pass a little bit of current, very little, maybe a few milliamps at 60 hertz. And so you might get a little zap or tingle off of the chassis if something like that happens, but it's not going to be the same as if you just tied this straight to here, straight to the metal chassis, if that makes any sense. This capacitor typically was an old wax capacitor, and they can short circuit very easily. They should really be replaced with a Y2 safety rated capacitor that's designed to fail open and not pass any current. If there's say a lightning strike or something nearby. And you also don't want to oversize this thing. Probably a 0.05 is about as big as you'd want to go, and whatever they factory put in. If you put in like a 1 microfarad or something, it'd be able to pass a lot of current to the chassis in the case of a short circuit. And you could get, you know, a potentially fatal shock off of that chassis.
Hey, Rob, how about what if you go smaller on that capacitor? A lot of the safety caps I see are 0.01 or 0.02.
Yeah.
Are those fine?
I would err on the side of smaller. A lot of times I use a 0.01, even if it had a 0.05 or 047 on it. And it works just fine because at radio frequency, it's still, you know, 2 or 3 ohms to the chassis. So all of your shielding and things like that still work. So this is connected basically to B minus, the 0 signal point through that capacitor. So at RF, everything's grounded. So it's got to be there. Does that make any sense?
Yeah.
Right here it says often 01 will work just fine, is even safer. Again, you should always, for that capacitor, use a Y2 safety rated capacitor. The best way to handle this is actually to install, if you can, a 3-wire grounding cord and tie the chassis directly to that green wire that goes back to the neutral bus in case there is a dead short to the chassis, and that would blow, in the worst case scenario, your circuit breaker at the panel. But if you put a small fuse in here, like a 1 amp or 2 amp or something like that, that fuse should blow before there's a hell of a lot of damage. And you know, you don't want 12 amps of current flowing through there, and it's just not enough to trip a 15 amp circuit breaker. So the best way is to put a 3-wire cord and a fuse that goes before anything, before a switch, before anything. If you do not install a 3-wire cord, again, you would want to put in a polarized cord, and hopefully the house is wired correctly, and the wide blade would go to the neutral, so it would be actually, hopefully, at ground potential back in the panel, and that will be the one that goes to the B minus, so that you know that when it's plugged in properly, if your outlets are correct, the low voltage side goes to the B minus, and then is connected to the chassis with the safety capacitor. Again, we've got a fuse here before anything, before the switch on the volume control, etc. I would not rely on this filament. You know, it's supposed to be a fuse, but I would not rely on it on the 35W4 or whatever you've got, maybe a 35Z5 rectifier tube, etc. Transformer type radio, the high voltage side is isolated by the transformer from the metal chassis. This is taken from an original unmodified schematic of an old Zenith. And here they just have probably a wax capacitor going across the lines here. Now, if that shorts, it's not great, but hopefully it would, you know, trip circuit breaker, because there would be unlimited amount of current flowing between these two lines. The high voltage side, again, is isolated by the from the transformer. So your ground here is not necessarily going to be hot. Now, if you got one of these and it has a short or leakage, and it can be from either side of the transformer, your chassis, because it's metal and it's floating, not really connected to anything other than ground, there's no return path here back to the neutral or a grounding pin here to blow a fuse or trip a circuit breaker. So this could be a hot chassis, even if you have a transformer radio. Now, they are a bit safer than the old AA5s with the quote-unquote hot chassis, but they can still be a problem. Again, much like doing the ungrounded or hot chassis type radios, your best policy on these, and especially important with a transformer type radio, is to just go ahead, like a console, you're probably going to have room to go ahead and put on a 3-wire cord. You're going to put that to ground, replace this with a safety capacitor, and put a fuse here. So
Rob, do you have a typo there? Because shouldn't that be an X2 capacitor?
No, it could be an X2 capacitor, but again, the X2 is designed to fail shorted, and that's supposed to cause a short circuit and let you know that I no longer have my line filter on it. Whether it's going to line to ground or across the two lines, it's probably better to use a Y2 safety capacitor, in my opinion. If there's anything,
we can use Y2s for everything then, right?
In my opinion, yes.
Okay.
Because the Y2 is designed to fail open. So if there's a lightning strike on the line or nearby and you get a spike, this thing will pop open, may or may not blow the fuse. Worst case scenario, you lose some line filtering and start picking up noise on your radio. Okay. This is kind of an overlooked thing too. If there are any separate powered devices, like in a console record player, speaker, etc., you should run a ground wire to those too, ideally. Should be at least as large as the power cord gauge, and tie it to the main grounded chassis, because there can be a short circuit in the record player, there can be a short circuit in the speaker, and those can be hot. And then you can have hot metal where it's exposed, even if the chassis is not hot because of a short. So it could occur out on a peripheral device, and if you tie it back to the chassis and ground, then it will blow the fuse instead of having a hot speaker. This actually happened. I had an ungrounded field coil speaker, and somewhere in there was a short circuit, and it became 450 volts DC because of the power supply was running through the field coil. And I shoved the chassis back a little bit to work on it, and pow, big old spark. So I put my meter and I measured about 450 volts. I grabbed the speaker in one hand and the chassis at the same time and shoved them. That was a short between the B plus going to the field coil and the speaker frame. If the speaker frame had a grounding wire like I just described running to it, the fuse would have blown, and I would have had to trace down the cause why it wasn't running, and it never would have become a hot speaker frame. Making connections, this is important. Don't just strip a wire and stick it under some random screw, and don't count on sheet metal screws. Remember, whether you have a fuse in your radio or not, you should have maximum current flow to that ground wire if there's a short circuit. Don't just solder it to the chassis. Best way is to put on a crimp-on connector on stranded wire, because they don't crimp well onto solid wire. And if you can't find a hole, make a hole. 1/8 inch is typical, just drill a hole somewhere. Make sure this is all clean and shiny, of course. Tie that thing down with a nut, and then put another nut on top of it and tighten that down. That'll keep some pinhead from coming along with a screwdriver later and say, oh, I'm going to make some adjustments and try to take that screw out. I'm talking about the owner of the radio who might be just totally clueless. This way the screw won't come out. With a single nut, you can back the screw out and it'll get loose. It may not come all the way out, but now this thing's just flopping around up here. This way it's locked. Okay. So that's my recommendation. And you can crimp and solder this, but do crimp it first, please. Fuses. If you're simply replacing a fuse, of course, you're going to have something on the fuse holder or the label of the unit. You might see that more typically, say, on a 1970s stereo receiver or something, where it's going to say, use a 1 amp, 250 volt fuse, etc. Stick with that. Typically, you're going to want to keep the amp rating of the fuse at about 150 to 200% of the normal running current. And when you turn the radio on, there's going to be a short surge while the filaments heat up, and that's fine. That's not going to blow your fuse unless you're, seriously undersized. Don't use some fuse that you found for a car, something like that, because it might be rated at 12 volts. And if the fuse tries to open a short circuit, 120 volts AC can arc across that little gaps. You'll want to use a regular 250 volt rated fuse. Fast blows, I've never had a problem with them. Good rule of thumb is 1 amp for tabletop radios. You can go less, but they're kind of hard to find, and the National Electrical Code generally recognizes a 1 amp fuse as being minimum standard size. That would be, you would pick the next size up, which would be a 1 amp fuse from the running current. You got a record player or something like that, you might want to go with a 1.5 or 2 amp. But a fuse like this is going to blow more reliably and faster, and with less arc damage or chances of sparks flying and starting the cabinet on fire, than relying on that 15 or 20 amp circuit breaker on the mains to trip. And that's what I got.